Yes, welcome back students, welcome back, welcome to my channel. So today I came to you a super magic for finding the multiplicative inverse of a square matrix. So already we have a basic formula for finding the inverse of a square matrix, which is A inverse equals to adjoint A by det A. Okay. So for the existence of the inverse, det A should be det A should be not equals to 0. Then only inverse exists. Okay. So and we have a tradition formula, this one. So for finding the adjoint A, first of all, what is adjoint A? So the transpose of a matrix, which is formed of all the elements of A are replaced by their cofactors. It is called adjoint of A. Okay, then we'll get that inverse of a matrix. Okay, I think here we'll get the time while finding the cofactors of all the 9 elements. Okay, so no need to worry. Here I'm going to give the super magic for you. Okay, yes, within 30 seconds we are going to get that multiplicative inverse. Yes, let us see. So first of all, please find out to det A. So I'm going to expand with respect to R1. Yes, come on. So which is 3 of minus 6 minus 1 minus 7, which is minus 5 of 4 minus 1 3 plus 7 of is 2 plus 3 5. Yes, which is minus 21 minus 15 plus 35. So which is minus 1 not equals to 0. That means so A inverse exists. Right? Yeah. So det A not equal to 0. Now what I am going to find is adjoint of A. Yes, let us see here the magic starts. Let us see. So for finding the A inverse, okay, please write this the matrix as it is. So which is 3 2 1 5 minus 3 1 and 7 1 2. Okay, let us see here what I am going to do is, so anyway this is column 1 and column 2, C1 and C2. This C1 and C2, and again I am going to write, okay, as it is column 1 and column 2, which is 3 2 1 5 minus 3 and 1. Okay, yes, then after, so here is the horizontally, this is row 1 and this is row 2. These two rows, and again writing as it is. Okay, so which is 3 5 7 3 5. Right, and the second row is 2 minus 3 1 2 minus 3. Is it right? So first of all the matrix I am going to write as it is. Then after C1 C2, first two columns, and again I am writing, and row 1 and row 2, and again I am writing. Then after we are going to do one thing, remove this first row and first column. First row and first column are removing. Okay, yes, then after I am going to write the adjoint matrix. Let us see. So here adjoint A equals to, okay, yes, let us see. So for these elements, so please take the cross multiplication of this one. Please take the cross multiplication. Okay, it is a minus 6 minus 1 minus 7. And here we are going to take for these elements cross multiplication like column wise, but those values are writing row wise. That is the thing. Okay, then after please take for these two 7 minus 10, okay, which is minus 3. Okay, then after for these two, this is 5 plus 21, 5 plus 21, which is 26. Yes, coming to the next one. Okay, so which is for these two, yes, for these two. Okay, 1 minus 4 minus 3. Okay, yes, then after these two, this is 3 2, so 6 minus 7, which is minus 1. Okay, then after 2 7, so 14 minus 3 is 11. Taking the cross multiplication of the elements, so column wise, the elements are writing row wise. Yes, coming to the last, okay, here these two. Okay, 2 plus 3, which is 5. Okay, next 5 minus 3, which is 2. Okay, yes, and minus 9 minus 10, minus 19. That's it. This is the adjoint of A completed. Okay, yes. So after getting the adjoint of A, I think you know that. Then what is the formula for finding the multiplicative inverse? So A inverse is equals to adjoint by det A. So det A value already, which is minus 1. Then what is the inverse of what the problem is? So now A inverse equals to, already that is minus 1 of all those elements. So which is, you got that value, 7 3 minus 26, 3 1 minus 11, and 5 minus 5 minus 2 and plus 9. Okay, yes, so come on, you can check that, you can follow, you can use that one method, traditional method, and after that you can follow this method. Please check that. I think within 30 seconds we are going to complete this one. Okay, come on, have a look. Yes, students, a problem for you. So A is 1 3 by 3 matrix and find its multiplicative inverse. Okay, yes, you can follow that your traditional method, and after that you can follow this super magic. Okay, yes, and you can compare these two. Okay, yes, so come on. So by using that super magic, you can find out this one. So within less time you will get that problem. Okay, yes, so come on. Please make a note and complete that. Okay, yes. Yes, students. So one more model for you. A is a square matrix which is 3 by 3. Then find the value of A cube minus 6A square plus 7A plus 2I value. Okay, yeah, generally we think that. So first of all we should find A cube next to 6A square, next to 7A, next to 2Y. Come on, it will take nearly 5 to 10 minutes. Okay, after finding the A cube, like, okay, just without using this one, I'm going to use that one method. Okay, for that you have to know that one concept. This is a characteristic equation. So what is the characteristic equation? So A is any square matrix. Yes, A is any square matrix. Okay, such that modulus of, delta of A minus lambda I equals to 0. Determinant of A minus lambda I equals to 0. So which is called the characteristic of the matrix A, which satisfies the matrix A satisfies the equation. So which is called characteristic equation. Yes, come on. So what is that? First of all, A minus lambda I, come on, A minus lambda. This is the matrix A minus lambda into identity. So which is, so I'm going to find it. First of all, I'm going to write A minus lambda I, A minus lambda I. So that is, so 1 minus lambda, right, diagonal elements, 1 minus lambda, which is 2 minus lambda, and this is 3 minus lambda, and the remaining elements, which is 0 2, and it is 0 1 and 2 0. For this matrix I am going to take the determinant. Yes, come on, find out. So its determinant is 1 minus lambda of, okay, 1 minus lambda of, so which is 2 minus lambda into 3 minus lambda minus 0. Yes, 0. Next, the second element is with respect to expanding with respect to R1. Next element is 0. Okay, leave it. And plus 2 into last element, plus 2 into 0 minus plus 2 into, so yes, it is 0 minus 2 of 2 minus lambda. Okay, yes, so which is 1 minus lambda of, okay, yes, it is 1 minus lambda of, this part is, it is 6 minus 5 lambda plus lambda square. Okay, 6 minus 5 lambda plus lambda square, and which is, so minus 4 of 2 minus lambda, right, minus 4 of 2 minus lambda. Yes, come on, the total which is 6 minus 5 lambda plus lambda square and minus 6 lambda plus 5 lambda square minus lambda cube. Okay, yes, minus lambda cube, and the second one, this one is the minus 8 plus 4 lambda equals to 0. Yes, A minus lambda by delta of A minus lambda, which is equating to 0. Okay, so it is equating to 0. Come on, totally simplify that value. Okay, which is lambda cube. Okay, yes, lambda cube, and lambda square is 5 lambda square, 6 lambda square. Okay, all the terms transform to right side, which is minus 6 lambda square. Okay, yes, minus 6 and the lambda terms, so minus 5 minus 6 minus 11 minus 11, so which is plus 4 minus 7, this is plus 7 lambda. Okay, yes, plus 7 lambda, and whatever the constant is 6 minus 8 minus 2, transform the side, plus 2 equals to 0. Yes, this is your characteristic equation. right? Which is called characteristic equation. Yes, and this characteristic equation satisfied by the matrix A. Come on, the total value is transforming. I am going to write in terms of the matrix A. That is A cube minus 6A square plus 7A plus 2. But all these are the matrices, that is a number. Okay, we should not write 2. 2 of identity matrix is equals to 0. Come on. A cube minus 6A square plus 7A plus 2I equals to 0. Yes, very simple thing. If we know this one, what's that? Which is characteristic equation. Okay, come on students, make a note. Yes, students, one problem for you. So A is one matrix is given and A minus lambda I is a singular matrix. A minus lambda is a singular matrix. Indirectly they have given one condition. Its determinant is equals to 0, which is our characteristic equation. Then which of the following option is correct? Okay. Yes, so come on, please follow that to the characteristic equation and find out that answer and write your answer in the comment box. Come on students, make a note. Yes, students, one more model in case of inverse. So A is a non-singular matrix that not equals to 0, that means A inverse exists and which is satisfying a condition. So that is A square minus 5A plus 7I equals to 0. Okay, in that case find A inverse. Same model, one more problem. Okay, let us see. So come to the first problem. So I have taken A square minus 5A plus 7 times of identity equals to 0. Okay, so from this equation how to get inverse? Okay, so come on. So throughout the equation take out that A inverse. Okay, both sides multiplying with A inverse. Okay, so which is A square. Can I write like this? A into A of A inverse minus 5A A inverse plus 7 into identity of A inverse equals to 0 matrix into A inverse. Okay, here what I have done here, A inverse totally throughout the equation multiplying with A inverse matrix. Am I right? So for this one A inverse, second term A inverse, third term A inverse, right side. Okay, so here please observe this one. A matrix is multiplied with multiplicative inverse. I think we'll get identity. Okay, so which is A into identity minus 5 into identity. Here also A into A inverse is identity plus 7 times of, okay, any matrix is multiplied with identity, we get the same matrix, which is inverse is equals to right side 0 matrix. So here we want the only inverse matrix. So this can be written as 7 into inverse matrix equals to, these terms are sending to right side. This is, okay, first of all, what about this one is identity matrix is multiplied with A, which is A minus 5 times of identity. So 5 times of A minus A, right? 5 times of identity minus A. Then I can write, so inverse matrix A inverse equals to 1/7 of, which is 5 times of identity minus A. That is very simple thing. It's a very important thing. Come on students, make a note and you can try the second problem. Okay, and send the answers in the comment box. Okay, so I think the students, you like this method, this shortcut. So please subscribe my channel. Okay, and comment and like that. Thank you so much.